2, 3, and 4. Count what you have now. Don't count what you don't have. Count what you have now. Don't count what you don't have. Find that you have so much.
Welcome to VTutor, the online tutoring service offered by yours truly, the VTutor, without a name as of right now. Today we're going to be working on some Math SL questions and principles. And to tackle this subject, we've come with this question here. And so this question has asked you essentially, consider x is equal to the log 242 of 243 times the log 241 of 242 times the log 240 of 241, and so on and so forth until we hit log 3 of 4. And so we're trying to find a solution where x will be equal to all of these log functions multiplied together. And so, of course, there is the straightforward solution of work all of these things out, all these logs out by hand or on a calculator if you want, and then multiply them all together. But if you did that, you'd be done in maybe about a year, and you'd have found all of your mistakes in maybe about 10 more years. So I wouldn't say that's the best approach. So let's look at this a little bit deeper. We have, if you notice, it looks almost like this function is counting down in a very strange way. So we have the log of something, the log thing of a higher number, and then the next one is a log lower number of the previous number, right? And it keeps on going forever that way. It's going to get one lower each time. And if you look at this here, you can notice another pattern is that this number seems to be equal to this number after it, and so on and so forth. Like right here, we have 242 to 242. And of course, down here, I'll have 240 and then supposedly 241. So what can we do with this pattern? Well, if we look in our formula booklets, if we look at topic 1, 1.7 SL, we'll find a little formula called the change of base law, and it looks a little something like this here. Yep. And so what this says is that the log thing of thing 2 is going to be equal to the log anything else of thing 2 over the log anything else of thing, right? So in this case, we could turn, using this change of base rule, we could turn log 242 of 243 into log 243 over log 242. Okay, great. Now what we can do after this is we can go on and we can do this for the next one, right? So let's look at this. This is going to be log 242, right, over log 241. 41. And, well, yeah, let's clean this up a little bit. Can keep going for the next one if you'd like. We got log 241 over log of 240, right? And I think you can maybe pick up on a pattern here. We're getting the same thing on the bottom as is on top in the next term. If you multiplied these terms together, what you'd find is you'd have log 243 by log 242 all over log 242 by log 241, right? And whenever you have the same thing on top as the bottom, you can essentially cancel them both out, right? It's going to be equal to 1. Anything times 1 is equal to itself. And this pattern would actually go on all the way down. See, you got it again. And this pattern would continue going down until we get to the point where we have log 5 over log of 4. And then, of course, we're going to have the last term is going to be log 4 over log of 3. These terms will cancel, this term will cancel, and presumably all of the terms in between will have canceled, right? So what are we left with? Well, we have the log 3 on the bottom, and we go all the way back to the beginning. We're going to have the log 243 on top. So if we rewrite this here, we can rewrite it as log of 243 over the log of 3. And so what's this? Well, these are both log 10. This isn't exactly simple to figure out, but what we can do again using the change of base rules is we can put this together into one term. So we can turn this into the log 3 of 243. Okay, this is getting somewheres. And now let's turn this into exponential form, right? See if maybe we can find an answer. So this is going to become, well, really, this should be an arrow here. 243, right, is equal to 3, right? Because this is what log is asking. It's 3 to the power of what makes 243. So 3 to the power of x makes 243. So let's just sub some things in here. I think one we all know is 3 to the power of 3 is going to give you 27, right? One more of that, maybe 3 to the power of 4. What's that? It's going to be 81. And 3 to the power of 5. Oh, that's going to be 243. So therefore, our answer right there is going to be x is equal to 5. Perfect. So there you go. That's how you use the change the base rules to solve one of these problems where the bases are counting down. So thank you for watching the video, and until next time, I hope you do some good maths.
Can't you see?